Saxon Algebra 1, Lesson 86. Dun, 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 dun. Another fanfare. We're going to divide polynomials, you guys, and it's going to be amazing and awesome. The nice thing about this operation is that you don't have to do it a lot in ongoing algebra problems. It's not something we're going to spend a lot of time on. It does show up on things like SATs and college placement exams. Not sure how many college standardized tests you'll be taking, like SATs and ACTs. It's going to be interesting to see what happens when you guys are ready to be seniors, whether those will still be a thing. But college placement tests will always exist, and that's a test that a college gives you, not to see if they want to let you in, but to just make sure you start in the right class. Most four-year universities, no matter what your degree is, you will need to take at least one college-level math class. So like one of my daughters was a creative writing major. She had to take one college-level math class. Another daughter was an art major. Another daughter was linguistics. They all had to take one college-level math class. My fourth daughter was an astronomy major, so she took a million math classes. That was different. But no matter what you're interested in, you usually have to take at least one college-level math class to get even a 2-year degree. So college placement exams are real. Boy, I just got off on a big tangent on your futures, didn't I? You're like, dude, I'm just trying to get through to the weekend. Don't talk to me about college. I understand. I'm sorry. Let me remind for you the rules of long division. You learned this a ways back. You learned that long division is a big fat pain, but you learned that it's a series of steps that you repeat over and over and over and over again in order to do this monstrous thing called long division. I want to just remind you of what they are. First, you estimate. And we'll talk about this in just a minute in more detail. So if you're like, I don't know what she's talking about, that's fine. Then you multiply. Then you subtract. Then you bring down. This is called an algorithm, which means a series of steps that are repeated. Whoops. Series of steps that are repeated. Okay? No wonder fourth graders find it so hard to learn this. It's an algorithm, you guys. That's what makes long division so flippin' hard, is that you have to keep doing these 4 relatively complicated steps over and over and over, and you have to do them in this same order and then start at the top again and do them again. It's annoying and it's hard. So I'm completely sympathetic to the drama of long division, but we're going to do it again today. I'm going to show you how these steps still apply to when we're using division with polynomials, and we just slightly tweak them, but pretty much they exist just as you learned them back in the day, and still need reminders on them sometimes, right? So here's the way our problems are going to look. Let's see how many we have. Yeah, there's quite a few. There's 6 of them. We'll see what happens there. Okay, it says divide. Excuse me. Divide this whole thing by x. Okay, for this kind of division, we use division boxes, just like old school long division. So give yourself a little bit of room for your answer, and then we're going to rewrite this thing inside the box and then put this on the outside. Now, when you're doing your homework, obviously you don't have to write it like this. You'll just read that in the book, but I wanted to show you that's the way the problems are stated in the book, and you have to figure out which one goes in the box and which one goes out of the box. The number that we're dividing goes inside. What we're dividing by goes outside. All right, so we're going to start with this whole thing. We're going to start with the number 1 step, and that's estimate. So what we have to ask ourselves is, what do we multiply times x to get 3x squared. Oh, it should be cubed. What do we multiply? Spoilers. What do we multiply times x to get 3x cubed? Okay, well that would be 3x squared, right? Because then when you multiply it, you're adding one more x. Okay, that looks good. So that's estimate. Now we actually multiply 3x cubed. Now we subtract, and this is going to be trickier later. We want to put parentheses around this and the minus sign on the outside. 3x cubed minus 3x cubed. Yeah, that looks good. That cancels. And so then we bring down 7x. Okay, we made it through the first time. Woo! What do we have to multiply times x to get 7x? Notice the way I'm saying that question when I estimate. What do I have to multiply times this to get this? What do I have to multiply by this to get this? That's the way I ask myself the question. What do I have to multiply? Times x to get, first it was 3x squared, now it's 7x, right? Okay, what do I have to multiply there? 7, positive 7, so I can put in a plus 7. We're going to be adding or subtracting these terms as need be. Now we multiply 7 times x, yep, it's 7x. Whoops, too bad I can't write. Subtract, parentheses and a minus sign. Beautiful, it all goes away. Bring down minus x. What do we have to multiply? Times x to get minus x, minus 1. Multiply, minus x. Subtract, that becomes a plus x. I circle it, I'll talk more about that later. Minus x plus x is 0. We're done. So our final answer is 3x squared plus 7 x. Wait a minute, I did something wrong. Oh, I see what I did. This should have been a squared, and then this would have been 7x. Sorry, I messed that up. Don't worry, we'll figure that out the next time. Because we would have said, what do we have to multiply times x to get 7x squared, and you would have said 7x, right? Because the 2 then would go together to make 2. All right, I made that harder than it needed to be. Let's go on. Let's see what else I can do to ruin your day. JK, I would never. All right, now we're going to do another one. We're supposed to divide 12 x to the 12th, Lord have mercy, minus 8x to the 8th plus 4x to the 6th. I'm like triple checking these exponents. And we divide all of this by 4x to the 4th. Okay? Estimate, multiply, subtract, bring down. First we estimate. What do we have to multiply by this to get this? Well, we're going to need a 3. And then we're going to need some more x's. We already have 4. We need 12. We know that when we're combining matching bases, we add the exponents. So that sounds like an 8 to me, right? 4 plus 8 is 12. Okay, now we actually multiply 12 times 8 to the 12th. We subtract it. Yes. Get 0, we bring down. Okay, what do we have to multiply by this to get this? Well, the 4, to get minus 8, we would need minus 2. And then we're going to need some more x's, right? Okay, nice, nice, nice. So far, so good. Now we actually multiply. We get minus 8x to the 8. But we're subtracting it. Those two go together, turn this into a plus. I circle it to say just pay attention to that. And now that all cancels out again. Oh, I love this. 4x to the 6th. Okay, what do we multiply? Well, it's only going to go in there. Let's see. It's going to have to be times x squared, right? So that we'll add them together. I was looking at something else in the book and trying not to confuse myself. Okay, so then when we multiply, we get 4x to the 6. We don't have anything more to subtract and bring down, so there's our final answer. Yay, I got it right this time. I didn't go crazy in the middle. This was example 86.2. Okay, 86.3. This time, John's giving us a mess. He says to divide this divide that by, oh my gosh, what is this? What is this? Messy, 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 John. We don't like it. All right, let's clean up his creation. This needs to be written in proper descending order. Here's an x to the third term. Here's an x to the squared term. They need to be flipped. So I'm going to write it better. 3x to the third, not plus. Then the minus 2x squared. That's going to confuse me, isn't it? Plus 5x plus 50. Now, we're going to divide it by a binomial. Yeah, we are. It's going to be fine. But we're going to write that in the proper order too. Okay? Now we are ready to dive in. Now, take a look at this. When we do our estimating with a binomial out here, we don't pay any attention to this part. I'm going to use another marker to cover it up. We don't care about the -3 when we're estimating. We only look at the x, okay, when we estimate. What do we need to multiply by x to get 3x cubed? We'll need 3x squared, right? So in estimating, I totally ignore that. But I'm underlining estimating because when we get to step 2 and we multiply, now we have to pay attention to it. Okay, so we can't ignore it forever, but when estimating, we ignore that. Now we multiply. 3x squared times x, that's 3x cubed. Now we do the second part, minus 9x squared. Notice how it's lining right up with my x squared term. Oh, John, you're too good. Now, we put the parentheses around and subtract. Remember how I told you it was kind of tricky? 3x squared minus 3x squared goes to 0. That's fine. This is where it gets weird. This minus turns this sign plus. So what I do is I turn it into a plus sign, right? The two minuses go together to make a plus. I circle it to show I changed that. Because if you don't circle it, you're never going to remember, but did I change it already or did I not yet change it? So I always change it and immediately circle it so I will remind myself, you changed it, you're good. Now I can add these. Minus 2x squared plus 9x squared gives me 7x squared. You with me? Okay, algorithm time, back up to the top. We're estimating. I hide that. What do I have to multiply by x to get 7x squared? I'm going to need positive 7x. Right? Now we multiply, and we do both of them. That becomes 7x squared. And then it becomes minus 21x. Oh, I didn't bring down. I'll bring down my 5x. Okay? Parentheses and a minus sign. That's why I was putting the parentheses up here. Even though I technically didn't need them up here, I knew that later I would, so I wanted to get them in place right away in your brain. Okay, two minuses make a plus, and I circle it. Now I have 26x. And I'll bring down the 50. Okay? I'm looking at the answers. Yes. Beautiful. Okay, now we're back to estimating. What do I have to multiply by x to get 26x? Oh, 26. 26 times x is 26x. That worked out well. 26 times minus 3. Well, let's do that. 26 times 3, or 6 times 3 is 18. 6, 7. That's 78. And I'm multiplying by minus 3, so it's minus 78. Parentheses and a minus sign. I'm ready to subtract. Those go away. The minuses become a plus. I circle it really fast before my brain gets confused. 50 plus 78 equals 128. Now, I don't have anything more to bring down, and I ask myself, what do I have to multiply by x to get 128? Nothing that we can do, so I'm done. Now, this is a remainder. What do I do with a remainder? Same thing we do in regular division, except we put a plus sign there. I'm going to make a fraction, 128 over x minus 3. Okay? So that's what we do with our remainder. We put it over this expression and write it on the end. So this is our final answer. And guess what? It's correct. Yay! Looks weird, right? Here, let me show you John's. See? We got it right. 3x squared plus 7x plus 26 plus 128 over x minus 3. Okay. All right. Can you live with this? It's kind of whack, isn't it? I mean, it's kind of long division, but it's kind of not. All right. Example 86.4. We're going to keep chugging away. We have 2 more to go. That's a lie. We have 3 more to go. That's all right. You'll forget all this by the time you're ready to do your homework, so it's fine. Okay, what I'm going to do, though, is I'm not going to copy it down the wrong way. I'm going to see, once again, John's up to shenanigans, 2x cubed, and then I need the x squared term, then the x, then the 4, and I'll flip this around. I always want the x to be first. So I'm going to write it the correct way. I'm going to be super careful to match the signs to the proper term. Got lots of room for my answer up here. And then it's x minus 2. All right, here we go. Where's my hide the other number estimating pen? We hide it for the estimating. What do we have to multiply by x to get 2x cubed, 2x squared? This becomes 2x cubed. And this becomes minus 4x squared. It lines up so nicely. Later, John's going to monkey with us on that. This subtracts. These two make a plus. And when I, quote unquote, subtract, because technically I'm adding, I get 3x squared. And then I bring down the minus x. Okay? That minus turned that minus sign into a plus. Minus x squared plus 4x squared is 3x squared. So many different steps of different things we've learned over the years are all coming together in this problem. It's pretty cool. All right, estimating. Don't want to look at that minus 2. What do we have to multiply by x to get 3x squared? 3x, right? There's the 3x squared, and now it'll be minus 6x. But we're subtracting that. We put the parentheses around. That's gone. That changes to a plus, and this becomes 5x. Bring down the 4. Okay. What do we have to multiply this x by in order to get 5x? Oh, that's pretty cute, right? When we multiply, we take the pen away. 5x minus 10, but we're subtracting, so this becomes a plus. That's gone, and this ends up as 14. There's nothing more to bring down. X won't multiply by anything to give me 14. So we know we have met the end of our trail here. That's our remainder. We don't just write R, like you know how sometimes in division you do that. You just write like R 14. No, we write it out. We go plus 14 on the top and this on the bottom. And that's our correct answer. Yay. Okay. Now we're going to have another curveball thrown at us. Again, John's giving us things out of order, so we're going to correct it. But as we're putting the big number into its proper space, we notice something weird. 3x to the third, I'm going to leave a gap there. You'll know why in just a second. No, I did not copy this problem wrong. There's a cube, and there's a plain x, and there's a plain number, but there's no x squared term. We're missing one of the numbers in the sequence. So look what we can do. When we're missing a number in the sequence, we add it with a coefficient of 0. We can add to fill in any gaps by using a 0. Do you guys know that trick? If you slash the 0, it's so that people know it's not an O. So I could technically do that, just so you're clear. Yeah, so we fill in the empty places with the appropriate variable and a coefficient of 0. That doesn't have any value. It's just holding the place open for us, right? Okay, so now we follow our whole routine and see how it plays out with this wacky term. Estimate 3, what do we multiply by x to get 3x to the third? 3x squared. Take away the pen and multiply. This is 3x to the third, and this would be minus 9x to the squared. That's not how you say it, but just pretend. All right, we subtract with parentheses. That goes away. This goes positive. And now to our 0x squared, we add 9. So now we have 9x squared. All's good in the world. Bring down the 2x, minus 2x. Estimate. What do we multiply by x to get 9x squared? Well, excuse me, I'm not bored at all, I promise. Nor am I tired, just Johnny. Okay, x times 9x will give us the 9x squared. Take away our hiding pen. Yes, indeed, when we multiply, we actually get that, but we also get minus 27x. Make sense? This is being subtracted. That goes away. This turns into a positive. Remember to circle, please. Minus 2 plus 27 gives us 25x, and then we'll bring down our 5. One more time through the algorithm. What do we multiply by x to get 25x? 25, 25x, and then we get minus 75, right? And we subtract. This goes positive, that goes away. So we have 80. Nothing more to bring down. X won't go into 80, so we know we've hit the end. So we do plus 80 over x minus 3. That is our final answer. If this happened to be a negative number, we would put a minus sign right there. If it's positive, we put a plus sign. Okay? Hallelujah. And we just have one more. Is there something different? Oh, yes, there's something kooky about this one, too. I'll give us a fresh page. These need a lot of room. I hope by now that algorithm is kind of sticking in your head. I'm going to write it again. estimate x only. Multiply x minus 3, just as an example, right? 3 subtract, use parentheses, and 4 bring down. Okay, there's some of the special things we have to remember when dividing by polynomials, but see, it's the same 4 flipping steps as we've always had. All right, divide x cubed minus 4. Okay, I left a big gap there because I can see right from the get-go, John has been remiss. We're missing the squared term and the plain number term. So I'll add those in a minute. Let me just get the other number. This is x minus 3. Okay? So this fits with, these examples work well for this problem because when we estimate, we'll only use the x, but when we multiply, we'll use the x minus 3. Okay, so what do we do about these gaps? Same thing as last time, we just have to add 2 of them. And that's fine, we can add them all day if we need to. But we can't leave those spaces empty or we'll just get confused, it'll make a big mess. All right. What do we have to multiply by x to get x to the third? X squared. X to the third minus 3x to the squared. We subtract. That cancels. That turns into a positive. 3x squared plus 0x I bring down. X, to get that, we need 3x without any squared. Then we get 3x squared, and then we get minus 9x. You with me? Okay. That turns into a plus. That cancels. This becomes 9x minus 4. I'm just giving you a second to breathe. I know I'm going really fast. Ready? Estimating x only. What do we multiply by x to get 9x? Oh, 9. 9 times x is 9x. 9 times minus 3 is minus 27, but we are subtracting. That cancels, that goes positive, and we get 23 right here. X does not go into 23. We don't have anything more to bring down. We're done. It's positive, so we say plus 23 over x minus 3. That, gentlemen, is the final answer of the final problem of lesson 86. Feel smart. These are hard problems, and you know what? We went from super easy on that first problem. Remember, we just had a plain x. We didn't even have the binomial out here, to having gaps in here. We will practice these every year of algebra. They really won't get any harder than this, right? Filling in the gaps is about the hardest thing that happens. The hardest thing about these problems is remembering how to use the algorithm for long division with the little tweaks in it for polynomials. That's me keeping away the cougars, Parent Trap style. Okay, that's enough. If you don't want to know what I'm talking about, I'm very sorry. Goodbye.